On October 22, 1963, over the quiet farmland of Wiltshire, England, a prototype aircraft designated G-ASHG entered a routine stall test at 16,000 feet. The pilots pitched nose up, bled off airspeed, and waited for the aerodynamic shudder that would signal the stall. It never came. Instead, something happened that no engineer had predicted. The aircraft's nose rose, the airflow over the wings separated violently, and the turbulent wake blanketed the T-tail mounted high above the fuselage. The elevators went dead. Full nose-down input produced nothing. The aircraft locked into a flat, stable descent at over 10,000 feet per minute. 7 men, including chief test pilot and former world speed record holder Michael Lithgow, rode the aircraft into Crat Hill. There were no survivors. The phenomenon would be named the Deep Stall. The aircraft was the BAC-111, Britain's audacious bid to build the world's first purpose-built short-haul jet airliner. For decades after, conventional wisdom held a simple truth about the aviation industry. America builds the jets, Britain builds the ideas, then loses. The BAC-111 had beaten Douglas to the market by a full year, secured orders from American Airlines itself, and outsold every competitor in its class by the mid-1960s. It was, by every measurable standard, the aircraft that proved short-haul jet travel was commercially viable. Then, Boeing showed up, not with an original concept, but with something far more dangerous. A wider fuselage borrowed from the 707, engines moved under the wings, and a production philosophy built to scale. The Boeing 737 launched in February 1965, entering service in 1968, and went on to become the best-selling commercial aircraft in history, with over 12,400 deliveries and counting, until the A320 came knocking. But here's what makes no sense. The BAC-111 had a 2-year head start. It had paying customers on 3 continents. It had cracked the seemingly impenetrable American market. 244 aircraft across 2 decades should have been the foundation for a dynasty, not a footnote. Yet today, almost nobody outside aviation enthusiasts remembers the aircraft that created the entire short-haul jet market. So, how did the plane that changed everything become the blueprint for its own replacement? To understand why the BAC-111 matters, we need to understand what flying short distances looked like in the late 1950s. Long-haul aviation had already entered the jet age. The Boeing 707 and de Havilland Comet were shrinking oceans. But regional routes, the 300 to 800 nautical mile sectors connecting cities within continents, remained stubbornly trapped in the propeller era. The Vickers Viscount, the Fokker F-27, these were fine aircraft, reliable, economical, and painfully slow. Passengers who had tasted jet travel on transatlantic routes increasingly resented climbing aboard a turboprop for the short hop from London to Paris. Airlines knew demand existed for a short-haul jet, but the economics seemed impossible. Jets burned more fuel. Short sectors meant more takeoffs and landings per day, accelerating airframe fatigue. Turnaround times had to be ruthlessly fast. The aircraft that solved this equation would own an enormous market. In July 1956, British European Airways produced a paper explicitly calling for a new generation of jet-powered regional aircraft. Hunting Aircraft responded with the H-107, a modest concept for a 30-seat jet with rear-mounted engines. Then came the forced merger. In 1960, the British government consolidated its fractured aerospace industry. Hunting, Vickers, Bristol, and English Electric merged to form the British Aircraft Corporation. BAC inherited the H-107 concept and immediately recognized that 30 seats was not enough. It scaled to 80 seats, widened the fuselage to 5 abreast seating, kept the twin rear-mounted Rolls-Royce Spey engines and the elegant T-tail, and designated it the BAC-111. On May 9, 1961, British United Airways placed the launch order for 10 aircraft. The short-haul jet age had officially begun. The 111's maiden flight on August 20, 1963, beat the Douglas DC-9 to the air by approximately 18 months. After the devastating deep stall crash in October and the subsequent redesign incorporating stick shaker and stick pusher systems, the aircraft entered commercial service with BUA in April 1965 on European short-haul routes. But BAC wasn't content with the British market, it wanted America. What happened next stunned the US aviation establishment. On July 17, 1963, American Airlines, a powerful domestic carrier in the United States, placed an order for 15 firm BAC 111s with 15 options, a British aircraft flying American airline colors on American domestic routes. Braniff International followed. The order book swelled past £200 million, with 2/3 of production destined for export. BAC had aspirations for 400 orders. The aircraft was proving something the entire industry needed to see. Passengers would pay for jet speed on short sectors. Airlines could turn a profit doing it. The short-haul jet wasn't a luxury experiment. It was the future of regional aviation. But the US establishment fought back. The Civil Aeronautics Board attempted to block orders from Bonanza, the original Frontier, and Ozark Airlines, citing protectionist policies favoring domestic manufacturers. The message was clear. Britain had proven the market existed. Now, America intended to own it. Here's the cruel irony embedded in the 111's design. The very configuration that made it first to market, the rear-mounted engines and T-tail, contained the seeds of its competitive obsolescence. Rear-mounted engines created a beautifully quiet cabin. Passengers loved it. The wings stayed aerodynamically clean. Engineers loved it, but the physics extracted a punishing toll. Mounting 2 Rolls-Royce Spey turbofans on the rear fuselage required massively reinforced tail structure. That meant weight. Every additional kilogram of structural reinforcement in the tail was a kilogram that couldn't be allocated to passengers or fuel. The fuselage width, constrained by the original Hunting H107 lineage, permitted only fiberglass seating in a 2-3 configuration. And then there was the deep stall problem. BAC had solved it with stick pushers and wing leading edge modifications, but the fundamental vulnerability remained. Every T-tail aircraft required those mechanical safeguards. Every safeguard added weight, complexity, and certification burden. The Rolls-Royce Spey engines themselves presented limitations. In hot and high conditions, the Spey 512 lost thrust dramatically. The competing Pratt & Whitney JT8D engines, powering American designs, suffered far less in identical conditions. BAC attempted to evolve. The Stretch Series 500, which flew on June 30, 1967, expanded capacity to 119 seats. The Series 475 combined the shorter fuselage with a larger wing for rough field operations. But each variant was an incremental modification of the same fundamental architecture. The rear engine stayed, the narrow fuselage stayed, the T-tail stayed. What BAC needed was a clean sheet redesign. What BAC got was a competitor who had been watching very closely. Boeing began preliminary design work on the 737 in May 1964, a full year after the 111's first flight, and squarely in the middle of BAC American's sales triumph. The timing was not coincidental. Boeing had watched the 111 validate an entire market category and decided to build a better version of it. But Boeing didn't copy the 111's design. Boeing studied the 111's compromises. The first and most consequential decision was the fuselage. Rather than designing a bespoke narrow tube like BAC had done, Boeing took the upper fuselage cross-section directly from the 707 and 727. This was an act of industrial ruthlessness disguised as engineering efficiency. The wider fuselage accommodated 6 abreast seating in a 3-3 configuration. Instantly, the 737 could carry more passengers per flight than the 111 on an identical route. Airlines saw higher revenue per departure. The mathematics were devastating. The second decision was the engines. Boeing abandoned the rear-mounted configuration entirely and placed the Pratt & Whitney JT8D turbofans under the wings. This single change eliminated 3 problems simultaneously. The deep stall vanished. With no T-tail and no rear-mounted engine nacelles disrupting airflow to the horizontal stabilizer, the 737 faced no risk of the phenomenon that had killed Michael Lithgow and his crew. Structural weight dropped. Without the need for a reinforced tail section to carry engine mass, Boeing saved hundreds of kilograms that could be allocated to fuel or passengers. Maintenance became simpler. Mechanics addressed underwing engines from the ground with standard equipment. Rear-mounted engines required scaffolding, specialized platforms, and significantly more labor hours. Boeing also reused 707 and 727 components extensively, from cockpit systems to structural assemblies, slashing development time and cost. The 737 formally launched in February 1965, less than a year after design work began. Lufthansa placed the launch order. When the 737-100 entered service in 1968, it carried more passengers in a wider cabin, with engines that performed better in hot conditions, on an airframe that was cheaper to maintain and free of the deep stall risk. It wasn't just a competitor to the 111, it was the 111's business case, rebuilt from the ground up with every limitation removed. The 111 didn't die suddenly, it faded, and the matter of its fading reveals everything about why first-mover advantage means nothing without the ability to scale. BAC explored modernized variants. The proposed Series 700 would have been a significant stretch. The Series 800, powered by CFM56 engines and seating approximately 150 passengers, might have kept the airline competitive into the 1990s. Neither reached production. In 1977, BAC merged with Hawker Siddeley to form British Aerospace, which ultimately chose to join the European Airbus consortium rather than fund another generation of 111 development. The Romanian licensing deal of 1979 represented a final attempt to extend the aircraft's commercial life. The agreement projected 22 locally built airframes, with Rolls-Royce Spey engines manufactured under license. Romania's Rombak factory completed just 9 aircraft before the Eastern Bloc's economic collapse ended the program. By the late 1980s, noise regulations effectively killed the 111 in Western markets. The original Spey engines were low bypass turbofans that produced extraordinary noise. Hush kits existed but cost way more than many of the aging airframes were worth. European and North American operators retired their fleets en masse, selling aircraft to carriers in Africa and the developing world. In the United States, the exodus was swift. Aloha Airlines briefly operated 111s, but quickly replaced them with Boeing 737-200s. By late 1986, Allegheny, formerly Mohawk, was the sole remaining American operator, with approximately 20 aircraft. The jet that American airline pilots had once called Britain's Revenge was quietly vanishing from the continent it had conquered. The final indignity, or perhaps the final honor, came on May 6, 2019, when Northrop Grumman retired the last operational BAC 111 globally. The aircraft had been serving as a flying testbed for F-35 fighter jet avionics, equipped with a military avionics system fitted in a modified nose. 56 years after its maiden flight, the 111's operational life ended not with a revenue passenger, but with a military radar system overhead. The numbers tell the strategic story with brutal clarity. The BAC 111 produced 244 aircraft across 2 decades of manufacturing. The Boeing 737 family has delivered over 12,400 and counting. But the significance of the 111 isn't about the 111. And it isn't really about Boeing, it's about what happens when a pioneer validates a market it cannot scale. You see, BAC did everything right in the innovation phase. It identified the gap between turboprops and long-haul jets. It designed an aircraft specifically for short sectors with fast turnarounds. It engineered solutions to the deep stall problem that improved safety across the entire industry. It broke into the American market through sheer product superiority. overcoming active regulatory hostility from the Civics Aeronautics Board. What BAC couldn't do was iterate at industrial scale. The British aerospace industry of the 1960s was a fragmented collection of recently merged companies sharing facilities at Herne and Weybridge. Boeing was a vertically integrated manufacturing colossus with existing production lines, existing supply chains, and existing fuselage tooling from the 707 and 727 programs. When Boeing decided to enter the short-haul market, the development cost was dramatically lower because they weren't starting from scratch. It was adapting proven components. The wider fuselage already existed. The engine integration philosophy already existed. The manufacturing infrastructure already existed. BAC had to invent the market and the aircraft simultaneously. Boeing only had to build the aircraft. The market was already proven. This pattern, pioneer validates, incumbent captures, repeats across infrastructure. But in aviation, the consequences are uniquely permanent. Aircraft programs last decades. Once airlines commit to the 737, their maintenance infrastructure, pilot training, and spare parts inventory all lock into that ecosystem. Switching costs becomes prohibitive. The first mover's window closes not gradually, but completely. The aviation industry has always measured an aircraft's program success in orders, deliveries, and fleet size. By those metrics, the BAC 111 was a modest success, while the Boeing 737 was a phenomenon. But the 737 didn't emerge from a vacuum. It emerged from watching a British aircraft prove that short-haul jet service was commercially viable. It emerged from studying the limitations of rear-mounted engines and T-tails. It emerged from recognizing that a wider fuselage meant more revenue per flight. Every design decision Boeing made on the 737 was informed by what the 111 had demonstrated and what the 111 had gotten wrong. The 111 democratized jet travel in ways that reshaped entire societies. In Britain, it became the workhorse of the package holiday revolution. Millions of working-class families experienced their first foreign holiday aboard a noisy 5-abreast 111, flying to the Mediterranean coasts of Spain and Greece through operators like Dan Air and British Caledonian. In the South Pacific, Air Pacific used the rugged Series 475 to bring jet service to short runway island destinations. In Central America, TACA introduced true jet service to the region using 111s. In Brazil, VASP and Trans-Brazil operated the aircraft during their turboprop-to-jet transition, where passengers affectionately nicknamed it the Jato. These contributions don't appear in Boeing's order book, but they appear in the market that Boeing's order book depends on. In 1963, 7 men died over Wiltshire, proving that a short-haul jet could work, that the deep stall could be understood and defeated, that the market existed. Their sacrifice produced the stick-pusher systems that protect every T-tail aircraft flying today. The aircraft produced the commercial proof that Boeing needed to justify the 737 program. 6 decades later, the 737 flies more passengers daily than the entire 111 fleet carried in its lifetime. 244 aircraft built across 20 years versus 12,400 and counting. A footnote in production numbers, a foundation in competitive history. The question isn't whether the BAC 111 changed aviation, it's whether the industry that was built on its blueprint is really willing to remember.